Hi to everyone. In this video, I'm just going to discuss about AVL trees. Actually, once if you are taking the tree table, we are having the two types of a tree table. One is the static and next one is the dynamic. Right? So, if it is of a static, insertions and deletions are known in advance. Okay, so no insertions and deletions will be performed in the static structure. Once if you are taking the dynamic, this term itself reveals a dynamic. It means you can perform the insertions and deletions once if it is needed, right? So the modifications you can do it in the dynamic tree table. Okay, it's a necessity of discussing about the static tree table and the dynamic tree table here is actually AVL tree is an example for the AVL tree is an example for the dynamic tree table. Why we are saying it as a dynamic tree table means here we are going to perform the insertions and deletions, and even we are going to customize the structure of the tree if it is needed. It's a necessity for customizing the structure of the AVL trees means actually AVL tree it's nothing but the high balanced binary tree. It's a height balanced binary tree. AVL tree is nothing but height balanced binary tree. Who introduced this trees is actually Adelson, Wellskin and Landis. So introduced this height balanced binary tree in the year 1962. So what it means it's actually a binary tree, but it's a height balanced binary tree. What are the conditions to be satisfied by this height balanced binary tree means you can take T as the binary tree, non-empty binary tree, right? So you can assume T as the non-empty binary tree. This T is said to be height balanced binary tree once if it satisfies the two conditions. What are the two conditions? First condition is TL and TR must be a height balanced tree. Height balanced tree. What is mean by this TL and TR means TL it's nothing but the left subtree and TR it's right subtree. So both TL and TR must be a height balanced subtree. This is one condition. And what's another condition means modulus of HL minus HR must be less than or equal to 1. What is mean by this HL? HL it's nothing but the height of the left one, right? And HR it's a height of the right subtree. Okay, So once if we are going to find out the difference between the HL and HR means these differences that means HL minus HR must be the values less than or equal to 1 means these differences should have the value either 0 or else minus 1 or else 1. It should have any of these values only. It should not have the values other than 0 or minus 1 or 1. If these two conditions are satisfied means then we can say set that tree as a height balanced binary tree. This condition should be satisfied for every nodes. Let's see an example for this one. Yes, consider this binary tree. So what are the two conditions? TL and TR must be a height balanced subtree, and then the height of the left and the height of the right subtrees differences must be less than or equal to 1, right? So in such a cases, you just consider these things. First, I am just going to find out the heights. The height for the node C is 0 and the height for the node B is 1 and for the height for the node A is 2. Actually, these are all the nodes. B and C are the nodes which is present on the right hand side. But once looking on the left hand side, we are not at all having any children. This tree is not at all having any children. So what happens here is, if I am just going to find out the differences HL minus HR means HL value will be 0 for all the nodes, but HR will be there. Okay, so even though the condition is satisfied for the nodes C and B, the condition is not all satisfied for the root node A. So we can say this tree as an height unbalanced binary tree. Okay. So what we are just going to do it here is, in order to make this tree into a height balanced binary tree, I am just going to redraw this diagram as B and here A and here I am taking C. So once if you are taking the value height for A is 0 and for height for B is also 0 and the height for the B is 1. But we have to trace the balance factor. Balance factor, it's nothing but the difference of height of the left subtree and the height of the right subtree only. And these balance factors should have the values either 0 or 1 or minus 1. Okay. So in order to trace that one, I am just going to find out the balance factor for every node. When I am calculating it for A, HL for A is 0 and HR for A is also 0. 0 minus 0, the balance factor will be 0. And in the same way for C also the balance factor will be 0. When I am going to calculate it for B, a height of the left subtree is 1. So for this one HL is 1 and for the right it's also 1. When I am going to calculate the balance factor, HL minus HR means For the B node also I am getting 0. Just look into these balanced factors here. All these balanced factors are within the range. What's the range? It's between the range -1 to -1 to 1. It means it can have the value either -1 or 0 or 1. So since it's having zeros only, we can conclude this 3 as a high balanced binary tree. So in order to bring out this high balanced binary tree, we are just going to perform some types of rotations. Okay. So if a tree is said to be a high balanced tree, means then you can call such a tree as an AVL trees. I have mentioned one thing. In order to make your unbalanced subtree, unbalanced binary tree into a high balanced binary tree, we are going to perform some types of rotations, no? And that type of rotations which will be called as AVL rotations. AVL rotations, that we will see it in the next video. If you are having any doubt in the introduction of AVL trees, means kindly post your queries in the comment section. Thank you.